The mighty Brahmaputra, the third largest river in the world and largest in India, with the width ranging from 1.2 kilometers to 18 kilometers. This river is also known as a moving ocean and has been bridged only 3 times in past. Hindustan Construction Company has a distinction of building 2 of these 3 bridges and is now building the 4th bridge at Bogibeel near Dibrugarh. The 4.94 kilometers long Bogibeel Road-cum-Rail bridge will be the 3rd longest bridge in India and largest over River Brahmaputra. This will be the first totally welded steel bridge of Indian Railways. It is a double-decked bridge having 2 railway tracks on a lower deck and a 3-lane road on the upper deck flanked by footpaths on each side. For constructing this mammoth bridge, HCC has set up huge facilities on the south bank of the river that will have 3 sequences of fabrication, assembly and launching. The fabrication shop has 2,000 metric tons per month capacity with 2 parallel bays. The process begins with fabrication of different parts which are joined together in the assembly yard to form a truss. Stacked steel plates, relocated by magnetic lifters on platforms, are carved using computer software-controlled CNC plasma cutting machine and oxy-fuel cutting machine. The edges are altered to match the thickness of the adjoining plate by scalloping, and rough edges are beveled using global line machines imported from Canada. HCC has assembled customized platforms in-house to fabricate and fit various joints employing gas metal arc welding or GMAW and saw welding. For ensuring an error-free welding, dye penetration testing, ultrasonic testing and magnetic particle testing was deployed by the project team. A specialized beam-making CMM machine from Italy is used for the first time in India for fabrication of box and eye sections using submerged arc welding or SAW procedure. A blasting gun is used to achieve surface roughness of SA 2.5 before applying paint. The intermediate and final spray coatings are performed in highly controlled climatic chamber with spray guns. These fabricated sections are then moved to the assembly shop where they are installed on their designated beds. They are guided to their correct positions through jacking and welded by GMAW and SAW process. These segments are arranged in a sequence and sent for the vertical assembly using horizontal lifters. After installation of the top and bottom girders, the final truss bridge dimension design chambers are examined thoroughly and approved to complete the fit-out. A nose is fabricated and fitted on the first truss before launching it on the piers. 1,000 tons hydraulic jacks and strand jacks linked with the substructures are used for moving the steel truss over the pillars. 2 sets of steel cable strands are anchored to the end cross beams of the truss and hauled by hydraulic jacks. The truss slides over the launching bearing with the help of sliding plates, which are inserted at one end and taken out at the other, moving the truss towards its desired position. In order to limit the required launching forces, the superstructure is pulled in 4 launching segments of 10 spans each. Thus, the superstructure is pulled over the pillars just like a train of 10 spans. With each span weighing 1700 metric tons, the pulling force required will be equivalent to pulling 26 Airbus A380s with maximum takeoff weight over 650 tons, put together without any wheels. Finally, the launching bearings are replaced by final bearings. The tracks are laid and the road is constructed adapting RCC construction. Fulfilling the electrical and other ancillary requirements, the assignment is completed. This Rs 1,328 crore project for Northeast Frontier Railways is another proof of HCC's immense expertise to accomplish mammoth tasks with utmost ease. This bridge will also have strategic importance for ease of transporting troops and supplies to Indian military bases.